So we're going to be graphing this rational equation. So the first thing we want to do is convert the expression into factored form. So if I look at the numerator, I can't factor it, so it stays x squared, but the denominator can be factored by difference of squares. So we open up double parentheses, one's a plus, one's a minus. X squared splits as x times x, and 1 splits as 1 times 1. To convert this to simplified form, we're looking to see if there's any matching factor in the numerator and denominator, and there isn't, so this is completely simplified. So in order to find the vertical asymptote, remember we're looking for what we can't plug in for x, so our restriction is we can't divide by 0, so we have to set each factor in the denominator equal to 0. So if I set x plus 1 equal to 0, I would get x equals negative 1. And if I set x minus 1 equal to 0, I would get x equals positive 1. So those are my vertical asymptotes. If I'm checking for any holes, I would see if there's a factor that got crossed out in the numerator and denominator, and there isn't because they didn't match, so there's no holes. So in order to find the horizontal asymptote, we are using that observation where we check the exponents, and in this case, the exponents match. So if they match, we're using the ratio of the numerator and denominator's coefficient, so it's just 1 divided by 1, or y equals 1. In order to find the x-intercept, we are essentially setting y equal to 0. And if you set y equal to 0, or if you set f of x equal to 0, really, in order to get an answer of 0, if you're simplifying this, the numerator has to be 0. So essentially, all you have to do is set this part equal to 0. So if you set x squared equal to 0, you would take the square root of both sides, and you would get x equals 0. So that's our x-intercept at 0, 0. For the y-intercept, we're going to be setting x equal to 0. So I'm plugging in 0 for x. So in the numerator, I would have 0 squared. And the denominator, I would have 0 squared minus 1. So this is 0 divided by negative 1, and 0 divided by any number is still 0. So the x and y-intercept are both at the origin, 0, 0. So let's go ahead and start graphing. So we're going to start with our vertical asymptotes at positive 1. So here's positive 1, and here's negative 1. And we're going to be drawing a dashed line here. So that's positive 1. Here's negative 1. Now let's check our horizontal asymptote. That's y equals positive 1. So here's positive 1 on the y-axis. So there's our horizontal asymptote. And then from here, we're going to plot our x and y intercept, which happen to be at the exact same spot at 0, 0. So from here, we want to pick some points in between on the right-hand side and on the left-hand side of our vertical asymptote. So let's start with in between. So we already have 0, 0, so let's do 1/2. So if I plug in 1/2 for x, I would have 1/2 squared divided by 1/2 squared minus 1. So this is 1/4 all over 1/4 minus 1. So this is 1/4 divided by 3/4. Sorry, that's negative 3/4. So if I divide that, I get negative 1/3. So at 1/2, it is negative 1/3 right here. And if I plug in negative 1/2, that's not going to change my answer because when you square the negatives, they're still positives. So I would still get negative 1/3 when I plug in negative 1/2. So that means the graph is looking like this in this middle section. So now I'm going to try a point in the right-hand side here. So I'm going to plug in 2 for x. So I would have 2 squared divided by 2 squared minus 1. So that's 4 all over 4 minus 1, which is 4/3, or 1 1/3. So at positive 2 to the right, I'm going 1 1/3 up. Okay, so let's try, let's plug in 4. So if I plug in 4 for x, I would have 4 squared over 4 squared minus 1, which is 16 over 16 minus 1, which is 16/15, which is 1 1/15. So at positive 4, I got 1 and 1/15, which is even smaller. So you could see that the graph is going to look like this. Now, if I plug in -2, it's going to be the exact same output as plugging in +2, because if you take -2 and square that, you would get the +4, and -2 squared minus 1 is still 4 minus 1, which is 3. So you get 4/3 or 1 and 1/3. So at -2, you get 1 and 1/3. And so the graph will look like this on the left-hand side here.